There's been an outbreak of cholera in the growing suburb of Harare called Budiriro. Cholera is a waterborne disease usually caused by eating food or drinking water contaminated with the cholera bacteria. Investigations show that boreholes are the main source of drinking water in the outbreak-prone areas. Water samples are taken from a nearby borehole that is suspected to be contaminated. The bacteriological analysis is positive for the presence of Vibrio cholera in the borehole, which confirms the source of the cholera outbreak. Based on these results, a decision is taken to investigate the functionality of the borehole and the possible cause of contamination. A full investigation of the borehole is needed. For this, MSF engineers and water specialists have fitted a vehicle with a full range of borehole diagnostic tools. The diagnostic toolkit includes an onboard control unit, a TV monitor, a visualization camera, a water sampling probe, and a data logging probe. Before the investigation can start, the team gets permission from city authorities to proceed with the diagnosis of the identified borehole. During the preparatory phase, the borehole drilling report and a geological map of the area is also collected to plan the intervention in a better way. Before the diagnostic work starts, the health promotion team goes door to door to tell the community that the borehole will be out of use and under rehabilitation. The day of the investigation has arrived. The vehicle with the diagnostic toolkit on board arrives at the borehole, along with the team from MSF and City of Harare. First, all the equipment is removed from the borehole. Then, the MSF team examines the head of the borehole, as this could be the possible cause of contamination. Next, the vehicle is aligned in front of the borehole so that the borehole diagnostic equipment can be lowered into the borehole from a fixed winch in the vehicle. From the first investigation, the team mounts a camera onto the probe, attaches it to the cable and lowers it into the borehole for a 360-degree view of the borehole. The team watch the investigation on the TV monitor in the vehicle, and all the intervention is recorded on a video recorder, including the snapshot taken inside the borehole. The information includes the static water level and water turbidity, the condition and depth of the installed casing, the position and condition of the slotted PVC casing, the total depth of the borehole, and the presence of any deposits at the bottom of the borehole. For the second investigation, the team sends a data logging probe down into the borehole. The data logging probe measures the temperature and conductivity of the water, the geological formations and aquifers present at different depths in the borehole. The information is recorded on a laptop attached to the probe. Next, the team sends a water sampling probe inside the borehole to collect water samples from the aquifers located at different depths. These will be tested for aquifer water quality supplying water to the borehole. For the last investigation, a submersible pump is inserted in the borehole to conduct a step and long-term pumping test. These tests are done to check the maximum productivity of the borehole and the productivity of the aquifers providing water to the borehole. The pump tests last between 24 to 72 hours. The pump tests also help drain the contaminated water out of the borehole while bringing in fresh water from surrounding aquifers. At the end of the pump tests, the MSF team takes water samples from the borehole for both chemical and bacteriological water quality analysis. Back at the MSF office, the team analyzes all the information gathered during the diagnostic investigations and decide on a possible cause of borehole contamination. Then they agree on a set of actions to rehabilitate the borehole, which are agreed with the city authorities and carried out on the ground. Once the rehabilitation is complete, the MSF team takes water samples from the borehole to do further water quality analysis to ensure the rehabilitation has been successful and the borehole is no longer contaminated. Once confirmed, the team then upgrades the rehabilitated borehole with a submersible pump fitted with inline chlorinator, tanks, apron, and tap stands. Then the rehabilitated borehole, along with the equipment, is handed back to the community who have been empowered to manage the borehole sustainably.